Hello, and welcome back to Our Living Climate, presented by the My Name is Climate Foundation. In our previous chapter, we explained how the atmosphere's natural blanket keeps our planet warm and habitable. Now, we explore the vast, deep system that stores and moves that warmth around the globe. We now begin Chapter 4, The Ocean, the Climate's Mighty Flywheel. Section 4.1, The Blue Planet.
From the quiet vantage point of space, our planet's most defining characteristic is not its brown and green continents, but the vast, shimmering blue that covers more than 70% of its surface. We call our planet Earth, but in many ways, it is ocean. This immense body of water is not just a passive feature, a backdrop for life. It is an active and powerful participant in the climate system. In fact, it is the most powerful regulator of them all. If the sun is the engine of the climate and the atmosphere is the blanket, then the ocean is the planet's mighty flywheel. A flywheel in a mechanical engine is a heavy wheel that stores rotational energy. Its mass and momentum resist sudden changes in speed, smoothing out fluctuations and ensuring the engine runs steadily. The ocean does the exact same for Earth's climate. Its sheer size and unique physical properties allow it to absorb, store, and move colossal amounts of energy, smoothing out temperature swings and moderating the climate for the entire globe. Without the ocean, our world would be a place of violent and extreme temperature changes, far less hospitable to life. In this chapter, we will explore the three profound ways the ocean shapes our world: as a heat battery, a global conveyor, and a carbon sink.
Section 4.2, The Planet's Great Heat Battery.
The first and most important role of the ocean is its incredible ability to store heat. This property is known as heat capacity. It is a measure of how much energy a substance can absorb before its own temperature increases. To understand this, think of a hot summer day at the beach. The dry sand can become scorching hot, too hot to walk on. It has a low heat capacity. It takes just a little solar energy to raise its temperature dramatically. But the ocean water, receiving the exact same amount of sunlight, remains cool and refreshing. It has an enormous heat capacity. It can absorb huge amounts of energy with only a small increase in its own temperature. The scale of the ocean's heat capacity is staggering. The top 3 meters, about 10 feet, of the ocean alone store as much heat as the Earth's entire atmosphere. This property makes the ocean the planet's great heat battery. It charges during the day and in the summer, absorbing vast quantities of solar energy and keeping the planet from getting too hot. It discharges at night and in the winter, slowly releasing that stored heat back into the atmosphere, keeping the planet from getting too cold. This is why coastal areas typically have much milder climates than inland regions. A city like Amsterdam, close to the sea, has cooler summers and milder winters than a city deep inside the continent at the same latitude. The ocean acts as a giant local thermostat. Globally, it performs this function for the entire planet, absorbing more than 90% of the excess heat that has been trapped by the thickening greenhouse gas blanket.
Section 4.3, A River in the Sea, the Global Conveyor Belt.
The ocean doesn't just store heat, it moves it. This function is just as critical as its role as a heat battery. It transports warmth from the equator toward the poles, acting as a global circulatory system. The primary driver of this circulation is a massive, slow-moving current known as the thermohaline circulation, or more descriptively, the global conveyor belt. The name itself tells us how it works. Thermo refers to heat, and haline refers to salt content. The circulation is driven by differences in water density, which is controlled by temperature and salinity. Here is the journey of a parcel of water on this global conveyor. Warm beginnings. Near the equator, the intense sun heats the surface water. Evaporation makes this water saltier. This warm, salty water flows near the surface toward the poles, with famous currents like the GulfStream carrying immense tropical heat into the North Atlantic. The Great Release. As this current travels north, it releases its heat into the atmosphere. This is a primary reason why Western Europe has a much milder climate than its latitude would suggest. London is at a higher latitude than Calgary, Canada, but experiences far less severe winters thanks to this ocean-borne heat. The Big Sink. Off the coast of Greenland and Iceland, the water becomes intensely cold. As some of it freezes into sea ice, the salt is left behind in the remaining water, making it even saltier. This combination of being very cold and very salty makes the water extremely dense. So dense, in fact, that it sinks, plunging thousands of meters to the deep ocean. The slow journey. This sinking water forms a deep, slow current that flows south, around Africa, and across the Indian and Pacific Oceans. This journey in the cold, dark depths can take up to 1,000 years. Rising again. Eventually, this deep water gradually mixes and rises back to the surface, a process called upwelling, primarily in the Pacific and Indian Oceans. There, it warms up and begins the long surface journey back to the North Atlantic, completing the cycle. This conveyor belt is the planet's circulatory system, constantly moving heat and nutrients around the globe, fundamentally shaping regional climates.
Section 4.4, the planet's carbon sponge.
Beyond heat, the ocean also plays a critical role in managing the Earth's carbon budget. It is a massive carbon sink, meaning it absorbs more carbon dioxide, CO2, than it releases. It has absorbed between a quarter and a third of all the CO2 released by human activities since the Industrial Revolution. It does this in two main ways: the solubility pump. Carbon dioxide from the atmosphere naturally dissolves in seawater. Cold water can hold much more dissolved gas than warm water. Think of how a cold can of soda stays fizzy longer than a warm one. When the cold, dense water sinks in the polar regions as part of the conveyor belt, it carries this dissolved CO2 with it down to the deep ocean, where it is locked away from the atmosphere for centuries. The biological pump. The ocean is teeming with microscopic plant-like organisms called phytoplankton. Like plants on land, they use photosynthesis to live, consuming CO2 and sunlight to create energy. When these organisms die or are eaten by other creatures, their carbon-rich organic matter sinks. Much of this marine snow is consumed on its way down, but a fraction of it makes it to the deep ocean floor, where the carbon is sequestered in sediments. This process constantly pumps carbon from the surface to the deep ocean.
Section 4.5, a stressed regulator.
For millennia, the ocean has been our planet's steadfast guardian. Its flywheel-like nature has kept the climate stable. Its currents have distributed heat, and its chemistry and biology have absorbed a huge portion of our carbon waste. But this silent, tireless service comes at a great cost. The flywheel is now under immense strain. By absorbing over 90% of our excess heat, the ocean itself is warming, leading to marine heat waves, coral bleaching, and stronger hurricanes. By absorbing so much CO2, its very chemistry is changing, a process called ocean acidification, which threatens shelled organisms from tiny plankton to oysters and corals. And scientists are concerned that the melting of glaciers pouring fresh water into the North Atlantic, could disrupt the sinking of dense water that drives the entire global conveyor belt. The ocean has been our greatest ally in moderating the effects of climate change so far. It has smoothed the ride, but it is not bottomless, and its patience is not infinite. Our next chapters will explore the other great regulators, the ice and the clouds, to see how they too are responding in a rapidly warming world.
End of Chapter 4, The Ocean, the Climate's Mighty Flywheel. That concludes Chapter 4, where we explored the ocean's immense power as a heat battery and global conveyor. From the deep blue, we now travel to the world of white. In our next chapter, we'll discover the role of the planet's ice. Find Chapter 5 on our YouTube channel playlist at My Name is Climate.